folks out there, but I just wanted to share with you some experiments I've been doing in the lab. What I have in here is some galinstan in some acidified iron 3 solution. And in addition to the iron 3, there's also just a little bit of copper 2 in the solution as well. I'm gonna do something here that's a little crazy. Hey, Gigabean, you guys are gonna love this. Hello, Econ. I just been messing around in the lab with some galinstan. You can see the liquid galinstan that I'm just messing around with in this petri dish. It's a liquid, so that little silvery thing is a alloy. Yeah, it's a first stream for sure. It's an alloy of gallium, indium, and tin. And I have it in a solution of iron 3. And it's also got some copper 2 in there. Hello, Dino. You guys are going to love this. I've had it working. I've got some video. I'm probably going to, edit this into a video at some point. But I just wanted to share with you something I've been messing around with in the lab. So, again, I have some liquid galinstan in a solution of acidified iron 3. There's also some copper 2 in here. Now check this out, man. I'm going to add some copper 2 crystals. This is copper 2 chloride. That's what's giving the green color. So the iron 3 solution is yellow, and the copper 2 imparts a blue color. I hope this works. If it doesn't work, what am I going to do? But we'll see. Just check this out. Come on, baby. You got to go for me. Okay. You can see some bubbles forming on the surface here. That's due to the formation of hydrogen gas, just a little bit. We'll see if we can't just coax this to do something with the iron. Come on, baby, there it goes. Look at that. So what's happening is there's a chemical reaction that occurs on the surface of the galinstan, and that chemical reaction lowers the surface tension. Happy New Year, Dino. It lowers the surface tension of the galinstan, and that allows it to spread out. And it's just doing all sorts of weird stuff. So, hey there, Poems. How you doing? Welcome aboard. I thought I'd show you guys some experiments I've been doing in the lab. This stuff is just really, really looking cool. Yeah, I'm not in the basement right now. Isn't that something, Hugh? Isn't that something? So, there's a liquid metal alloy called galinstan. It's like mercury, but it's much less toxic. Like, much less toxic. And so, it's appropriate for using in experiments in schools and stuff like that. And the galinstan has a certain surface tension to it. And you can see it kind of beads together, like a bead of liquid. But if I place some stuff in here, oh, there it goes. There it goes. If I place some copper crystals in there, reactions will happen on the surface of the galinstan, and that lowers its surface tension, and it allows it to spread out. So I was just messing around doing some experiments today in the lab. I thought I'd show you what I was doing. We'll try it again. I'm going to add a few copper 2 chloride crystals. It does seem like a worm, Yuki. So we're going to add a bit of the crystals here. This is where the magic happens. And I'm not sure how long it's going to run. Just do a little path there, straight across, okay? So we're going to just give this a little bip. And come on, baby. There it goes. So reactions happen on the surface of the liquid, and that lowers the surface tension of the liquid and allows it to spread out. There's a lot forming here. There's some copper metal that's being formed. You can see like some copper nanoparticles here. There's some iron. It's not dangerous, Dino. And you can see like the galinstan kind of becomes more putty-like the more it reacts. Isn't that crazy? Just really kind of beautiful. Yeah, the surface, the reactions on the surface cause the surface tension of the galinstan to drop, and that allows it to spread out a little better. You can see it's really getting putty-like. I've observed this before. Thank you there, Yuki. Yeah, can you see? It's like, look at that. I'm punching it here. I hope I can go back and get some footage from this later that I can edit into a video. Thank you there, Giga. How you doing there, Gerald? Yeah, look at how putty-like that is. Happy New Year, Giga. Well, I'm not going to be on here long because I probably want to capture just a little bit more footage that I can actually go through and edit. Hello there, Judge. Tell you what, we get a few more viewers on here, and we'll go ahead and add some crystals. Hello there, Vine. What do you say? Hello there, Anime, Lucas. Just a quick live I thought I'd do showing you guys. Happy New Year, Skyla. Happy New Year. Hello there, Dream. You want to do one more? You want to add some more crystals? What do you say? What do you guys think? Chris M, how you doing? Hey, Chris, what's going on, buddy? Good to see you, Chris. Sorry I haven't seen you in quite a while. Ara, hello, cute. That's about what it is here, poems for me as well. Sure, Horse Queen says they need a shout out and they'll subscribe. CC, good to see you. Is it mercury or gallium? Takeshi, it is galinstan, which is an alloy of gallium, indium, and tin. So that's what we're looking at. But it's also been perturbed a little bit. I've run some chemical reactions on the surface, and those chemical reactions have caused the composition of the metal alloy to change a little bit. Thank you there, K8. I appreciate that. Hey, Jacoby, what's going on? All right, let's go ahead and add some crystals of the copper 2 sulfate. Mr. Habib, I'm not ignoring you on purpose. I apologize. Here we go. Let's add some crystals of copper 2 chloride. And we're going to check out what happens. Maybe the reaction has run its course. I don't know. We're going to find out, though. We are going to find out. So I'm going to add a few crystals here. So I'm adding crystals of copper 2 chloride. This is an acidified mixture of iron 3 and iron 2. Favorite reactions of elements, as Dino. Yes, Cody, it is a petri dish. Here we go. Let's see if we can't get it to go. There it goes, baby. So when it hits the copper 2 crystals, reactions happen on the surface of the galinstan. You can actually see some kind of like a brown substance that's forming. That's metallic copper, like nanoparticles of copper that are forming on the surface. I agree there, Takeshi. I think I'm guilty as charged. Takeshi says my chemistry is more art than kaboom, and I'd agree with that. How you doing there, John? Thank you there, Cody. Why are they called petri dishes? I don't know. Any biologists in the chat can answer that for us? How do you think a concentrated silver nitrate solution would react with a galinstan? That's a great question. So that's going to depend on the reduction potentials of everything, which, let's see. Silver's going to be more easily reduced than either copper or iron, so sure. Yeah, we did make some nanoparticles of copper. What's the green liquid? It's an acidified mixture of both copper 2 and iron 3 solution. Hello there, I think. Thanks, Cody, for the subscription. Yuki, it does indeed look like venom. If you want to check out some of my videos on this, I'm trying to make a new one. You can check them out on this particular substance. And for any chemists out there who'd like to learn more, you can download this particular article. Thanks for the sub, Jay. Thanks for the sub. You can check out this article in the Journal of Chemical Education, Repetitive Deformation of Gallium-Based Liquid Metal in Acidified Copper 2 or Iron 3 Chloride Solution. So there's a citation right there. This is where I'm getting the work from. Ariel, how's it going? How you doing there, Mr. Feeling Good? So Barrett, what this is galinstan. Galinstan is a liquid metal alloy. I should probably get some fresh stuff to put in here. This stuff has been, when the reactions happen, the thing gets a lot more putty-like. So let me see if I can get some fresh galinstan in here. Let's see if I got any left. I do. There you go, there's a drop. See if I can get another drop in there. Here we go. In it goes. I spilled some on this. There we go. So you can see, oh, stay away, don't. You can see these guys are more liquid-like, and you can tell the surface tension of the fresh galinstan is higher. You can tell that because this is more spherical, and this is more, look at that. You can see there's a big difference between sort of this blob of galinstan and this more fresh piece that has not undergone the reactions. It does look a lot like mercury, I agree. Now let's see what happens if we pop them together, all right? I don't know. You can see this is like really sluggish, right? This big piece. Let's see if I can break off. There we go. All right, so we'll keep that over there. We're gonna see what happens when this more sluggish piece and this more fresh liquid-like piece, let's see what happens when they combine. Here we go. The water's green because there's a mixture of copper 2, which is blue, and iron 3, which is yellow. Yeah, it seems to be a little more flexible now. Forbidden juice. Mr. Feeling Good, it is galinstan, which is a liquid metal alloy consisting of gallium, indium, and tin. Happy New Year, everybody. Thank you there every day. This one's more sluggish. More reactions have happened on the surface of this one. This one's a little less sluggish. So I'm going to get a bit more in there, a bit more fresh galinstan. Try touching both to see the difference, says Nova. We'll try it again. Oh, let's keep them away. So this one's a bit more flexible. This one is more sluggish. I don't know if you can notice that. Thank you there, CuzTube. Here we go. Let's watch them coalesce. Happy New Year, chemically. Are they going to combine? Hope all's well with you too, Pacific. Should I nudge them or just let them see what they're going to do? If you look close, you can see on both of them, you can see some bubbles. That's due to the formation of hydrogen gas on the surface. That comes from iron, so there's iron in solution that reacts and forms on the surface of the galinstan, and then that goes on to react further to form hydrogen gas. You'll also see little tiny particles. All right, Gamer wants me to combine them. You'll see little tiny black particles. Those are copper nanotubes. Excuse me, copper nanoparticles. So we got people saying don't nudge, and we got some saying do. We're gonna try it here. We're gonna let them go ahead and pop them together. Nova, the solution is an acidified mixture of, there they go, stuck together, of copper 2 and iron 3. Happy New Year, David. All right, David, they've been combined. I have a YouTube channel for chemistry, but it only has one video. Got it. Happy New Year. All right, let's try putting a little bit more in here. Where'd I get my profile picture from? I had somebody draw it for me. What's going on, Cortez? I don't mess with mercury, Mr. Feelgood. It's not mercury. It is galinstan. Let's put a fresh little piece in there. Look at those fresh pieces. They're like little droplets. Yeah, very cool. Combine them together. Boop, in they go. I think all three metals, 7th. I apologize that I've not sat down and I don't have the redox potentials in my head, but I believe all three metals do indeed react with the dissolved metal ions. The redox potentials will tell you that. But it is indeed the gallium in the galinstan that reacts most vigorously in terms of thermodynamics. No, I don't have it. I'm not going to mess. I don't mess with mercury, Mr. Feeling. That is a cool reaction, chill guy. I've done that before. What are the 3 black spots? I think there are 2 now. So this is a liquid metal alloy called galinstan. It's 3 elements together: gallium, indium, and tin. It's about like 67% gallium. I think it's like 11% tin, and the remainder is indium. Why? Stupid. So That's the name of somebody. I'm not calling anybody stupid. They asked, why was one blob kind of slow and the other one fast? Nova, I wouldn't try this at home. Jacoby, I don't mess with mercury because I don't want to have to deal with all the safety considerations. I prefer to use easier stuff. So what's going on with the fast moving liquid and the slow moving liquid, here we'll add some here. There's some fast moving liquid. So this liquid is fresher, until it gets assumed. So the fresher liquid has not had reactions happen on its surface, and I don't know why this is happening. All I can tell you is I've messed with this enough empirically to know that as more reactions happen on the liquid metal alloy, it tends to get more sluggish. I don't particularly know what's going on. My guess is it's becoming more solid-like. That's my guess. But I do not know. I've not studied this enough to know. Go for it, gamer. Gamer, what's your question? It's galinstan. It's mostly gallium, but it's also indium and tin. Follow the electrons. There's a EP is winning the chat right now. I do have some copper. Go ahead, Cuz Tube. Fire away. I don't have anything in place to heat it. What would happen if you got that blob thing out? Well, we can find out. Isn't that cool? I wonder if it's still going to react if I put it in some copper 2 crystals. You guys want to see something cool with that? Let's do this. Here we go. I don't know every day. I mean, I've, you know, I don't mess with this quite enough. This is maybe the 10th or 11th time I've done this experiment. All right, let's see what happens if it hits those copper 2 crystals. Get ready. There it goes, man. Come on, baby. Look at that. Look at that happen. What in the world? So what's going on is chemical reactions happen on the surface of the galinstan. It lowers the surface tension of the galinstan, and that allows it to spread out. The dark, solid materials that you see over here, those are copper nanoparticles. And I think as those get, you'll notice that this thing will subsume them. It takes them into the liquid. I don't think subsume is a word, but the you know, as the copper nanoparticles become incorporated into the galinstan, it becomes a lot more sluggish and solid-like. Look at that. Isn't that cool, man? It's just like a putty. So yeah, very, very cool. So I think I need to get some footage of this that I'm going to use in a video for my channel. That's all I've been doing today. I've just been messing around in the lab today trying to get footage for a new video. And I just saw some cool stuff, and I thought I'd let you know what I saw. So this isn't going to be a long live. My lives are usually done on the weekend. I usually go on like, you know, like Friday, Saturday, Sunday. Is it magnetic? I don't know. Let's find out here. I don't think it is. I'm going to grab a magnet. Hold on a sec. I do not think so, but we are going to find out. So I've got a neodymium magnet here. Somebody suggested me testing to see if it's magnetic. So right here I've got my neodymium magnets. Let's just see if it pulls it. No, that was magnetic. That would definitely be moving toward the magnets, and it's not. So yeah, so thanks for hanging out, everybody. Temperature is roughly room temperature every day. Yeah, I want to get some footage of this stuff. So it's absorbing copper. Well, maybe you could make ferrofluid out of it with hey, 7th. That's a good idea, man. That's a good idea. Ain't no problem every day. Gallium is a metal, that's right. The green liquid is an acidified mixture of copper 2 and iron 3. So that's what we're looking at there. And this is really getting sluggish. Look at it. It's just, I don't know what's... Yeah. Could we make it like... That's interesting. All right, 7th. Well, thanks for hanging out, folks. I'm going to get some more footage, so I'm going to have to pop off of the live, but thanks for joining in while I'm doing some experiments. I might try that, Ariel. That's a great idea. Here, someone's asking how I get the green blob out. It's already in dilute HCl. So here, we're going to just suck some of this up, okay? So here I go. Just suck it up into this syringe. Yeah, you can see I'm pulling some of it out, and then I'll restore it, see? It's up here in the syringe. I'll squirt it back out so you can see it over here. Boom. And it wants to go back home. We'll pull a little more out. It's cool stuff, ain't it? And we'll squeeze this one out. So yeah, you can see that stay away. Pull a little more out. I wonder if as I'm doing this, I'm getting the more liquid-like stuff out. I don't know, maybe. Because it does seem a bit more liquid-like. Like, look at this. These pieces seem to move a little better. I don't know if that's smaller or if it's because I draw the more liquid. Look at this. Look at this thing, man. Maybe it's I just draw the more liquid-like stuff out. I don't really know. What is it? It is galinstan. It's a mixture of gallium, indium, and tin. Let's just see. I'll pop these together and see if they get more sluggish. Well, this blob seems... this blob seems less sluggish than this one, doesn't it? Makes me wonder as I pull out the liquid, more liquid-like stuff comes out and more solid-like stuff remains. If that's the case, this should be even more sluggish now. Look at that, it is. What the heck? Come on, man, that's cool. These are more like a liquid. Isn't that interesting? Yeah, this is like very liquid-like. All right, folks. Thanks for hanging out. That was a lot of fun, and we'll catch you next time.